Okay, so we are going to start part 2 of adding and subtracting uncommon denominators. And this time we're going to look at it again, and then, but I think you'll notice that something is a little bit different here. So if we add 1/3 plus 1/2, again, we're looking at our visual. Step 1 stays the same. So we have to look at the denominators. Are they the same? No. If they're not, we have to get a common denominator. So that's the same as it was before. Now, if you remember, we were asking ourselves before, can you turn one into the other? So could I turn the denominators, one denominator into the other by multiplying or dividing? In this case, you can't. You can't turn a 2 into a 3 or a 3 into a 2 by multiplying or dividing. So we have to teach you some tricks, some strategies for when you have a problem like this. So this first one is called the least common multiples method, or at least that's what we're calling it. I don't know if that's what it's really called, but that's what we're going to call it. So if you can't multiply the denominator, one to get to the other, you have to find the least common multiples. So multiples, again, are just, if you almost like skip counting your denominators. So we start by finding the multiples of the two denominators. So our denominators are 3 and 2, so we're going to find the multiples. So skip counting 3, 6, 9, 12, and I just did a few here. And then for 2, 2, 4, 6, 8, 10, 12, I just, again, did a few. And you need to find the least one, the smallest one that they have in common. So if you look at these, the smallest one they actually have in common is 6. So that means now that we have found the least common multiple between the two denominators, that is what we need to turn them into. So we need to turn the 3 into a 6 and the 2 into a 6 through multiplication. Okay, so that's where this is all sort of coming from. If we can do that, then that means we can then have a common denominator, and it'll be easy to solve. So to get a 3 into a 6, we need to multiply by 2. And remember, same rule, if you want to do that to the denominator, you have to do it to the numerator. And to get a 2 into a 6, you have to multiply by 3. And again, you got to do the same thing.
Yes.
So let's look at it over here with our fraction bars. So multiply the fractions so they have their least common multiple as their denominator. So this is, again, what we just saw on the screen before. I just have rewritten it here. So step 4, we just rewrite it after you multiply. So those became 2, 6 plus 3, 6. And then when we add them, it's as simple as just putting them together like we did before. So 2, 6 plus 3, 6 equals 5, 6. But
that was sort of hard.
It is kind of hard. So there, believe it or not, there is an easier way.
And I'll try to show you one other way, and hopefully it might be a little bit easier at least. So now we're going to look at 1/4 plus 2/3. And once again, we want to always look first at step 1. Oh, there we have visually 2. Are they the same number? Nope. They are not a common denominator, so we have to get there. So what we want to do is think about, well, if you're sort of getting confused finding the least common multiple, even though Mrs. Bush did an awesome job explaining it.
It was stellar. It really was.
It still can be tricky, even with Mrs. Bush explaining it that well. So I'm going to teach you another trick. What you can do instead is you can look at each of these denominators and you can just multiply each denominator by the other one. So for example, I see a 4 and a 3 and I can think, oh, well, 4 times 3 equals 12. So that's one way to think about it. So looking here though, the big thing is you still want to rewrite everything up here and keep things neat and organized so it's not jumbled up.
And so it's easy to forget a step if you don't write it.
Right. So here, I'm basically, if I'm looking at my 1/4, I'm just going to look here and multiply both the denominator and the numerator by 3, the other denominator here. And then I'm just going to flip-flop. Over here, I'm going to multiply by 4, and then also up by the numerator.
So if you can see, when we solve those, the 4 times 3 will give you 12, and the 3 times 4 will give you 12. So it's essentially turning it into the common denominator.
Yeah. So, once again, we just want to rewrite this. So instead of all this jumbled kind of stuff, we have something that looks like this now. Much easier to read. 3/12 plus 8/12. And so you're going to rewrite that. Now, we just want to see what that actually looks like here then. So our 1/4 turned into a 3/12, still even or equal to each other.
Mm-hmm.
And then our 1/3 is now 8/12 over here. And this is where it should look nice and easier, or nice and easy. You should breathe a sigh of relief. Okay, I know how to do this part. And then you just have to solve the problem.
Yep.
11/12.
Yep. So that was another way.
Yes.
And now there's one more. And this one, I actually just learned this year, and it's super cute.
It
so
is cute.
I'm excited to show it to you. Here's a little hint. It is a butterfly method. So we have, again, 3/5 plus 2/9. And again, we're going to ask ourselves the same question. Are the denominators the same? No. Can I turn one to the other? No. So here's another trick when you can't do that. So the first thing you're going to do is draw in 2 diagonal ovals, and we're going to end up making a butterfly. So these are going to become the wings. So in this case, we'll draw that diagonal oval to circle 3 and the 9, and then 2 and the 5. So it's almost like you're crisscrossing numerator to denominator. Okay, so it sort of looks like a butterfly.
Yeah, it's getting
Then you're going to give your butterfly some antenna, and I know. And then those, the wings, you multiply. And one way to think about it, the wings sort of look like a multiplication symbol, so that might help you remember. So you multiply the wings, so 3 times 9 gives you our first antenna, 27. 5 times 2 gives you our second antenna of 10. Then step 3, you have to give your poor little butterfly a body. So connect the bottom of its wings and then put the product of the denominators into it. So if you look at where they touch, so it touches this part and this part, so those are the 2 numbers that you're going to multiply, and you get 45. Now, the next step is to look at your problem. If the problem is addition, then you're going to add the antenna. If your problem is subtraction, you would subtract the antenna. So in this case, we have addition, so we will add the antenna, 27 plus 10, and then our body just becomes the denominator. Now I'm just going to go through and solve this. 27 plus 10 is 37. 37 45ths. So we solved it. So again, I know that's kind of a weird way, and honestly, I don't know how or who figured this out. It was not me. I wish I could take credit for it, but if this helps you remember all of the steps, by all means, go for it. So we have done 3 different ways. The least common multiple method, the multiplying the denominators method, where they multiplied by each other, and then the butterfly method. So which one makes the most sense to you?
And I was just thinking, sometimes it makes sense to try a couple and see. Like, you know, you might be able to, you might have a chance to try some in just a moment.
Yeah, and which one do you like?
I like number 2, actually.
I do too, actually. Maybe it's the way I learned when I was little.
Right. Butterfly method is cute, and that might be fun every now and then, but
yeah,
I like number 2.
I tend to go with 2. So you're going to pick the one you want, or if you want to try all of them, go for it. That is totally fine as well. But there are 4 problems for you to try. So again, look back, please, to see. Make sure you ask yourself all the questions from the steps. Pick one and try and solve it, and we will take a look at these tomorrow. So good luck. It's going to be really fun, I'm sure.